All right, so for this boost, welcome to the boost. I don't remember which one we are on, but we're gonna do Bash. We're gonna learn Bash in an hour, and we're only gonna learn enough of Bash to be dangerous. And by dangerous, I mean understand what's in your Bash RC file, which is where that's where you keep all your configurations and stuff like that. And so what does that mean, right? So if you know Bash, then you know that. Um, it's a shell language. What is a shell? A shell is the thing that you're interacting with in the terminal to make, things happen. It's called a shell because it's kind of like the outer shell and the kernel is in the middle, and it's the thing that we humans interact with in order to have something happen. That's what a shell is, a command shell is. And so, you can configure this thing. This is where you put all your configurations. And we're going to talk about what all this stuff is. So by the end of this video, hopefully within an hour or so, maybe 90 minutes, but hopefully we'll keep it under an hour, we should be done. And you should be able to understand everything that's in this video, in this particular file, including conditions. And this thing here is called a function. We're going to talk about that. This is an exported function. We'll talk about that. There are some parameter expansion things happening here that we may not have time to get to. We will talk about why we're not going to talk about regular expressions and what those are. But you got to know the shell. So the first thing to know about the shell is that you are already coding. So when you are interacting with your terminal on the command line, you are writing code. And I'm going to say it again. You are already a programmer. The second you started using the terminal, whether you did it from, WesTerm or the built-in terminal or just the terminal that's built into VS Code, as soon as you entered a command on the command line, you wrote shell code. What do I mean by that? So a shell is built around another thing called a REPL, a read, evaluate, print loop. And what that means is that you type a thing, ls-shell, for example, this is a command. And so the shell is pausing, it's waiting around on me until I execute the command. And as soon as I hit enter, it reads in that line, ls-shell, parses it apart, and then it says, okay, let's turn this into commands for the kernel. And in this case, and that's why we call Bash an interpreter. I covered that in the last video. But so what's the difference between, if you haven't watched the other boost video that I just did, holiday boost, we went through all the languages and what's the differences between interpreted and compiled languages. So it goes to the Bash interpreter, and the Bash interpreter interprets what you gave it, these things, ls space dash l, all of that, and interprets that into a bunch of system level commands that get communicated directly to the kernel of the system. Now, it's not directly the way it works, but that's for you. That's the way to understand it in general. Any time you do this, anytime you execute a command, it kicks off a process, and a process is another topic altogether. But essentially, what it is it's a running program. And while we're at it, let's look at all the running processes on the system. You can type top or htop, and you can see all of the running processes on the system. A lot of you probably are already familiar with this, but these are all of the things that are running on the system. Not every one of those is a process that started from a command line, but let me just give you a sense of this. If I wanted to do that, I could do while true, do sleep one, echo, hello, done. And then we have a running process that is now, sending its commands, it's doing its thing. In fact, if we wanted to, we can open up another window here and we can actually look at it. So let's grab, I wonder which process. Let's do PS3. Brew install, or you can do apt install PS3. This is, we're not covering this, so I'm just going to do this really fast. But it's important you understand processes because this is kind of a part of learning how to code on the shell, is knowing signals and stuff, and we haven't really covered that yet, and processes. So let's do C, and then let's do PS3. All right, so here you can see all of the running processes and where their parents came from and stuff. It's interesting it didn't render it. The font's the way it probably should have. So okay, so here you can see my tmux. This is my tmux running, and then you can see the bash. This is an interactive bash shell. As I said, it's a running program, right? My current bash shell is an ongoing program that's running. It's running an interpreter, the bash interpreter, and it's waiting around for a command, and then it runs it, and then it runs another command, and then it runs it. So it looks like there I have NeoVim open in another terminal. Okay, here's another one here. So here's bash. Okay, look at that. There's the process that I ran that kicked off the sleep, and then it's continuing. You can see too that this sleep command itself is a subshell as well. It's a sub process. And this is going to be really important when we come back to things. So the first thing I want you to understand is that what we're running here is this is a program, right? It is a programming language. The bash interpreter is running so that every single line is a program, and those lines go into a history file which you can look at and stuff. But if you put those same exact lines like I just did inside of a file, this one here, let's actually do it. I can turn this into a string, and let's write it to a file. We can write it to something in temp. We don't care. Temp foo, I guess. All right, so we're gonna deconstruct what I just did there, but I want you to see this. So now when I look at the content of that file, you can see that it has a script in there, right? Well, all I really have, I'm trying to show you that the stuff that I did on the command line is code. So temp foo, and now let's say, okay, so actually, how would we run it in here? Well, I can say, hey, bash interpreter, go run the stuff in this file. And I can say that, and it'll do it, right? I can also do it a different way. I can say, hey, bash, I want to send you a new file on standard input. We're going to get to all this indirection later. You should have already learned the command line a little bit, but we'll repeat it really quick. So let's do this. You can say, hey, bash, I want you to read. I'm going to give all of the content of that file to you as if it was typed in every line into bash, and it will do the same thing. Both of these are identical. I could do another one. Here's another one. I could do this. I could say cat bash temp foo into bash. All right, this is an important one, right? So I can send it into bash, right? So and frankly, if you know Vim, let's actually, well, I'm getting kind of carried away, but so let's go look at this. So I have this thing. So, but this is kind of hard to read. The semicolons are just line returns. That's it. They're line returns, and you can put those in there and put them out there like that. You can save it, and now it's the same thing. So bash temp foo, and it runs, right? All right. So next thing, can I just do temp foo like this and make it into a program? No, you can't. Why not? Because it doesn't have the right permissions on it. So it is only a file right now. So the takeaway of this is, and let me just make a mention of this. So foo to temp foo .sh, or if you want .bash, okay, foo .bash. I made videos about complaining about this before, and I'm going to tell you why. I'm going to show you why today. So you see how this has a suffix on the end of it? The takeaway, the long and short of it is it's the best practice to not put a suffix on a file unless there's a need for it. And most of the time, there's not a need for it. This is one of those times, though. Like if you have a file that's meant to just be executed by typing bash explicitly, and we haven't gotten to it yet, but included in another file, then it makes sense for you to leave it with a suffix on it. If you want to turn it into an executable, then you should drop the suffix so that it can kind of live by its own self, And let's actually do that. Let's move it. So what happens if I move the temp foo.bash file into temp foo, first of all, and then I give it more permissions. So we already did this. We already did that. Let's actually add some permissions on. Chmod, I have schmox. I have a command called schmox. Because I type it so much, it's fine. So we're going to make everything executable, all the permissions. We haven't gotten into permissions, but this is fine for your personal system, and make sure you understand permissions before you do this, but it's easy to type. So just type chmod plus chmod, whatever you want to call it, chmod. I've been saying chmod my whole life. Somebody probably thinks it's funny, but whatever. So now when you do ls-l on temp foo, you see it's a different color. It's executable and everything. And now I can just type temp foo, and it works. Okay, why does it work? Now, there's probably at least one or two veterans out there. There's probably one or two veterans out there who are going to look at this and go, why is that working? What's it missing? This is a trick question. Pause the video. I'm going to go ahead and answer it now. Go ahead and I'm going to think, why is that working? It should not be working, right? My veteran coders out there, scroll scripts are like, how the hell is that running? There's only one reason this is running. The reason this is running is because this is what happens. Okay, I'm going to go through the steps. When the shell, you remember that read, evaluate, print loop, right? So I'm going to talk to you about the evaluate step. When you type a command in, whether it be ls or it be our foo command, the first thing it does is it looks for more or less environment variables aside. It looks for the first argument on the command line, and it says, what is that thing? Right? And there are lots of ways to figure out what that thing is. So, the most reliable is the word type, because if you type, then it tells you exactly what it is. ls is aliased to a bunch of stuff. We'll talk about aliases later. But if I do type.pwd, it's a built-in. If I do type.temp foo, it said temp foo is temp foo. It's just a file. Type Perl. What is that? Perl is it tells you which one it is. A lot of veterans will tell you to use which here or command-v instead of type. We will cover all three of those and how they go together. But to tell you that the fact of the matter is they're not the same. And type is generally the one you're going to want to use if you are, you're just looking to see what a thing is. Why? Because very important things are included with type, like my function, clone function. It tells you the type of function and what it is. And if I was to do that, if I was to do which clone, it has no idea where it exists. If I do command-v clone, it doesn't know about it. It's like, okay, it's a command, but it's not really, right? So you do which clone and it can't find it. That's because it's a function. So if you have something that can be executed on the system, then you have to know what it is. You have to know what it is. So when you're looking at that, so again, what does bash do? Bash says, what is the first argument, essentially, and what is it? And then it decides what to do based on what it is. If it's a function in bash, it just runs the steps as if you had typed those steps in. If it is an alias like ls, it's exactly the same as if you typed what the alias has. Okay. In fact, if you do tab, but sometimes the alias will actually even expand. So an alias is exactly as if you type those letters in, exactly the same. And it literally injects those letters in and as if you had typed them. That does not work if you put it in a script, by the way. It's important that you know that. There are settings you can do to get around that, but by default it doesn't. And then the clone, it says, okay, clone is a function, I'm going to run it. Okay, but we still have lots of stuff to talk about. What if it is an actual command, a built-in? So in the case of BWD, type PWD, we have a built-in. So that means this is built in to the bash programming language, interpreted programming language. You can do man bash and you can see all 272 pages of bash. And we're going to kind of go through this quickly, but you can see that it is a built-in in here. And by the way, if you want a shorter version of that for any built-in, you can just type the help command, which bypasses going through the man page, and you can type pwd and it will show you only that section of that built-in. So is it a command? Yes. Everything we've talked about so far is a command, but what type of command is it? Is it an alias? Is it an actual executable, thing on the system, which is the main thing we're getting to? or is it a function, or is it a built-in? There's lots of things it could be, but what Bash does is it says what is it, and then based on that it does something. And if in our case, if the first thing on the line is a file, then it says, oh, okay, the first thing here, it's not an alias, it's not a built-in, it's not a function, it's an actual file. It's a file, right? And watch what happens if I take away the permissions, by the way. Chmod -x temp-foo. If I try to run it again, let's get the error. Permission denied. Okay, so Bash says, oh, okay, we have a file here. What are we going to do with this thing? And so the next thing it does, I'm not running WSL right now. So the next thing it does is it says, okay, it's a file. Well, what kind of file is it? Right? But before it even asks that, it says, can I run this file? Okay, this dude is trying this dude is trying to run this thing. He's trying to execute it. And can he even do that? Are we going to allow that? And so it looks at the file. It looks at the file, and the file says, okay, this file can be read and written. That means it's a text file. It's not designed to be run, to be executed. And it's like, denied, not happening. So so the next thing I have to do is I have to give, for security reasons, I have to give Bash the hint and say, okay, I want to run this. I want this to be executable. So that's where chmod +x comes in. And by the way, that's, it goes without saying, you probably understand my username now much better. That's where my username comes from. So RBX read, write, and execute. So it made it read and everything. Now it can be run. Now when I do it, it'll actually run it. And it's a thing. It's run, putting hello out. All right. So far so good, right? So it says, hey, it's executable and I can run it. Now there's one other thing though that it does that in this case it's not doing. All right, and I'm going to do this in a different language just to simulate what is going on. Okay, just to give you a sense of this, Perl foo. We're gonna do this with Perl, and so, well, I guess we could do it. There's lots of things we could do here. Should we do it in Go or Perl, guys? No, we need to do it in Perl because of the shebang line. Yeah, duh. All right, so let's actually do that. Let's make a new file. Touch, we're going to make a new file. Why we do that? Because you may not have permissions. I've been burned by this so many times. It's always better to make that before you open it, because if you open it and then you start editing it and you have permission to write it, then you got to figure out some other way to write it someplace else with :w, which you can do. It's just not unnecessarily complicated. So just create a new files with Touch. You'll never have that problem. So if you hit VI or Vim, either way, and then you get this thing. So let's actually... write some Perl code. So I'm doing this kind of on purpose. So wall1 print hello sleep. Is it sleep 1? I think my Perl's a little bit rusty. I'm not gonna lie. So all right. So let's do this. So Perl foo. I must have done it wrong. My sleep is too long. I think it might be is it milliseconds? Oh no, it's buffering. That's why. Yeah. I forgot I need to disable buffering. This is a Perl thing. Yeah. Is it 1? I think it is. Yeah, it's buffering. It was totally buffering. So I totally forgot about that. But anyway, so that worked, right? Now, let's do the same thing that we did to Bash. I'm doing this for a purpose, I promise. Okay, so for Bash, let's do the same thing. So how much time have we got? Okay, so on Bash, let's do the same thing. We're gonna chmod +x temp Perl foo, and then we're gonna run it. Temp Perl foo, right? Nope. Why? Okay, I want you to look at this error. This is really important to getting this. This is really, really important to understanding what's going on. Why did I get this error? What does this error mean? Pause the video, Come up with your own answers. Go ahead and enter it in the chat right now if you wouldn't mind. If you want to say what do you think is going on. This file is executable. What am I doing wrong? What am I doing wrong? Why won't it run? It's important you get this. It's really important you get this. If you understand this, you'll understand everything about interpreted languages in Unix-like systems. So, all right. So here we go. The reason it's not doing it is because, yes, it says, is this running runnable? It's like, fine, I'm going to try to run it. Okay, but there's a step between that we're missing. There's one more thing that the bash interpreter does is it says, okay, this is an interpreted language. Okay, it's a text file. So first of all, I guess it's two decisions. It says, okay, is this file compiled or is this file interpreted? And that goes with Laboost that we had last time. That's why I had to talk about interpreted languages, right? Because there's two types. This is also why you don't want to put a suffix on a thing. Let me show you what I'm talking about. So I'm actually going to compile a program in Golang. So let's write a program here. You're going to this will really help you understand a lot. And we're going to do the same thing for, let's see, time.sleep 1 times time.second, I think. All right, so, and then let's say fmt println hello. All right, same exact code, just in Go. Okay, now, remember I told you about the difference between compiled and interpreted languages? This is a quick little taste of this. I know this is about Bash, but you can't understand Bash until you understand how the system runs interpreted languages versus binary. So we're going to continue down this path. So what are we doing? At this point, we need to, I can't, look, some noob might think that they could just schmox that thing, schmod plus X, and have it run, right? No. Now, you can do this. You can do go run temp foo.go. Fun fact, this is actually faster than the Python interpreter. And this is not how Go is meant to be used, but it's still faster. It's crazy. So there we go. That's actually running. Now, go run, what go run does is basically the same thing as an interpreter. It does. It compiles it. It breaks it up into instructions. In fact, in the case of go run, an interpreter oftentimes will take the instructions and translate them without an intermediate compilation step. We talked about bytecode in the other video. In the case of Go, it always compiles it. That means it compiles the full program down to a temporary thing that you can't see, and then it runs that program. It just does it all in the background for you. Okay. So, but here's the cool thing. And now, so how do we build that thing? So let's do this. Let's do go build temp foo.go, and we'll build it into temp foo with 3 O's. How about that? So let's see, go build what am I doing? Name files must be .go files. I don't think I'm doing it here. I don't do this very much. I just use the regular go build. All right, so that actually made a foo. Okay, so let's move foo. So that, when we do go with this, so that built a go binary. And I don't know if you can see this, but it did. I mean, let's leave it here. What the hell? It doesn't matter. So you see how that file automatically got made as a thing? Check it out when we do type on this. It says foo is ./foo, right? And there's another command that you haven't learned about yet. It's called file, which will tell you that it's a Mako 64-bit executable ARM64. So this is a different command. So you could actually do the same thing. You can't do, clone isn't a file, right? But if you wanted to, you could do foo.go. This is a good hacker command, so it's good to know. And it's a C program ASCII text. Foo.go thinks it's C program. That's funny. That's interesting. Did not know that. Okay, it says, nope, that's an ASCII text program. Why is it ASCII text? Because I don't think it has a schmod on it anymore, right? What about temp, what was the other one? Perl foo? Okay, both ASCII texts. Even though they have schmods on them, it still thinks it's ASCII text. Why does it think it's ASCII text? All right, so, okay, so let me just show you what I'm talking about. So let's move the foo program into temp foo, okay? And now let's run it. Temp foo. I didn't have to schmod it or anything, and it runs, right? And it knew exactly what to do. So when I compile the program, the takeaway from that is when you compile a program, when you truly compile for the system, whether it's C, Go, Rust, whatever, Julia, Crystal, when you compile a program, it becomes immediately executable. And that means, in fact, extremely efficiently, because the interpreter sees the file, is like, oh, this is an ELF binary, which you can open in VI, by the way. There it is. This is an ELF binary. So it's actually a particularly special kind of binary. I don't even think this is an ELF binary. I think it might be a different kind. This is all binary data. This data goes straight into memory, runnable memory, and runs. It executes, just like the bash interpreter. We talked about that in the other video. I don't want to do it again. Plus, we're already 25 minutes in. So what we're trying to say is that's already ready to go. It's ready to run. It's extremely efficient, etc. The other programs have a problem though, right? Why? Because the computer still thinks they're just ASCII text, even though we put schmod on there. So let me repeat the error again. So let's do the Perl foo. This gets this problem. So here's the question one more time. Try to answer it for yourself. Why does temp foo work and temp Perl foo does not work? Why? What is the difference between the temp foo program and the Perl foo program? I think you can probably figure this out. Well, let me ask you another question. What program is actually running? Yeah, you got it. A couple of you got it. What program is actually running? In the case of temp foo, let me ask you, okay, in the case of temp foo with 3 O's, what program is actually running? Answer, the file itself, FOOO. That file is actually running. In the case of temp foo, in this case, what program is actually running to process that? In this case, bash. And even more specifically, the bash program that is currently running. Okay, so it's running bash. Because bash is a default shell. Because we are using bash, because bash is our default shell right now, and that's the one we're interacting with, the interpreter punts and says, well, I don't know what interpreter you're using, so I'll just see if it's bash. I don't know. You didn't tell me what kind of language it is, but I'm going to go ahead and try it. So it tries to use it using its own thing. This is where the shebang line comes in, and we're going to get there in a second. One last thing. What program is actually running when we run Perl foo? And this is a trick question. What program is actually producing those error messages? It's not Perl. It's bash. Bash is like, well, you didn't tell me what language this was. And by the way, even if you put a suffix on that, it does not help. Watch. Temp Perl foo.perl. PL is the extension. If I do temp Perl, this is an executable file and everything, and it still doesn't know what to run. Some people might think, hey, well, you put a suffix on there, that'll give the interpreter a hint. It'll know what to do. No, it doesn't. It doesn't. And there's lots of reasons not to use suffixes that we're going to get into later, that only noobs use suffixes. I swear to God. I have fights with people all the time about that. And I'm going to show you why. I'm going to very specifically, now that you know how interpreters work, I'm going to show you why it's a problem. You can probably already see where I'm going with this. You're going to see already where I'm going with this, right? So here we go. Next, how do we fix that? So this is where we were getting up to. So one of the steps, so the command line bash interpreter says, what kind of file is this? It says, oh, it's a compiled binary. I'm just going to run that right away. Here you go, kernel. But in the case of these two files, Perl foo and temp foo, FOO, it says, I don't know what to do, so I'm going to try to run it using me. I'm going to assume you're a text file and you're executable, so I assume you're going to be the thing. But there's a step in between there, and what it does is it says, is the first character of the file a hashtag, and is the second character of the file a bang, an exclamation point? And if that is true, the interpreter looks for the first 2 bytes of the file. And if the first 2 bytes are a hashtag and an exclamation point, commonly known as shebang, hashtag bang, shebang, if those 2 bytes of the beginning of the file are a hashtag, then the interpreter's like, oh, okay, then I'll do what you're telling me here. And it effectively does the same thing as we're doing here. You remember when we did this? You remember when we did this, bash foo, right? Okay, that worked, right? So this is what it's trying to do. This is effectively what it's trying to do. It's trying to do bash foo when you get the error, right? So because it's effectively assuming that's what you want to do, but that's actually not what we want to do. We want to do this, right? Okay, so let's do the Perl one first. So let's fix the Perl one. So let's give it that little hint at the top. I remember I told you the shebang, hashtag bang, and you can just put Perl here. A lot of people will be like, that doesn't work. Let's see. Let's see if it works. Nope, can't do it. It can't do it, right? And the reason for that is because anytime you do that first thing, if it finds it as a command, it has to look in your path. And so it has to, so like bash is actually not really bash. Perl is not really Perl. It's actually that. Okay. And you probably don't have, so let's go ahead and put that in there, right? So I'm doing the Perl one on purpose just to show you, make a point. All right, so then we had to do the actual bash one. By the way, this is a good opportunity to do some command line stuff. Watch this. I'm going to type which Perl, right? And now I'm going to convert which Perl into the output with the filter command. Bang, bang, 2 exclamation points, bash. So it says take that single line, run it, and replace this line with the output. There we go. So rather, if I don't remember that, I don't want to cut and paste it, bang, bang, bash it to Perl. Now I have this and I can join them together. And now we have opt homebrew bin. So now what? I didn't have to remember that. I didn't have to cut and paste. I didn't have to do any of that. I just did, filters. So now what? Now let's try it. Temp Perl foo. Hey, look at that. It's doing the thing that it's supposed to. It's not putting line returns because print has to have explicit line returns in Perl, which is a pain in the ass. You also have to chop everything. Okay, but here's the problem. Let's say I want to take this exact same program and I want to run it I'm actually going to do this. Let's go run it on Linux. So right now we're running under Unix. Let's go run it on Linux. Okay. So let's do that. We got our PowerShell up and running. No. All right. Let me see if I can. Yeah, let's exit some PowerShell here. All right. So here's a Linux system. Let's do the same thing. We're running under Windows. This is actually WSL2. So let's actually do exactly the same thing. Which Perl? Yep. Okay. So we have Perl on here because most systems do. What version is it? I wonder. So this is version 38 and not 50. That's interesting. You guys already know what it's going to do, right? But I want to show people so that we can see I'm producing the problems so that you see why we're doing the thing, which is my style of learning. I got to know why. All right. So I'm going to give you the problem so you can figure out why. So next we're going to say, okay, I want to do a thing and I'm going to make my program over here. I'm going to say, it's like, right. Perl foo again over here, Perl foo. And let's see if I can remember. While one, sleep one, print. God, I don't. We should probably do it right this time. Anyway, so we're gonna say hello, and then probably have to have \n. All right, so we need to force it to buffer the output, which is what this is about, which is a Perl thing. Don't worry. All right, and we already know on the first line we need a shebang line, right? So let's actually put the same shebang line. Yeah, but here's the problem. Watch. Remember that little trick I did? Which Perl? Bang, bang, bash. All right, user bin Perl. Okay, so let's put a shebang line in there, which is, by the way, pretty standard location for Perl. And so with shmosh Perl foo. All right, so now we have a Perl foo, and now we can run it. So it's not in temp, but I can do / the same way. So / Perl is the same as writing out temp. Is buffered. Yep. I need the unbuffered stuff. It actually does. Yes. Warning setting locale failed. What did I put in there? What did I put in there? I don't have my Perl FMG on here either, so I don't know what's going on with that. Please check the locus. What's going on with there? What did I do wrong, guys? What am I doing wrong? I got some Perl program error in here. I don't know what it is. I don't know. Line 4. I don't know. I'm learning. Advanced student embrace. This should work. Our supported install section. Falling back to standard steel cast syntax error. Blah. That's a buff. That's forcing buffered output, which you guys don't need to worry about. You know what? Let's drop that for now. Oh, that's what it was. It didn't have a semicolon. Yeah, you have to have semicolons in Perl. So let me do that one more time. I mean, this is not meant to be a lesson in Perl. Okay, that's interesting. The whole locale thing is really interesting. I wasn't guessing that would be a problem. If you take this out, let me show you. A lot of you don't care, but you see how it's not printing anything? It's not printing anything because the buffer hasn't filled up enough. Because Perl is more efficient than Bash, and so you have to force it to flush the buffer every time, the output buffer, and that's what that's about. This is not a lesson about Perl. This is a lesson about Bash, and there's some other problems here going back with the whole unset the C locale thing. So that's the thing we'll need to look at. But what I was trying to show you is that this line is wrong, right? It's user bin Perl. Like, what's up with that? Right? So it shouldn't be user bin Perl. What if we made it the same as the other one? What was it? It was homebrew something, right? I'm doing this on purpose to show you the point. The other one is opt homebrew bin Perl. Well, I don't have to show you, but you can probably guess there's no such thing. What happens if let's go back to the one that's faster than code on. Let's say that I wrote this code on WSL and I want to use it on my Unix machine, my Mac. Okay? What would be the problem if I put user bin Perl here? Now, this actually will work because there is a user bin Perl here. Let me show you. So temp Perl foo. It works, but it works for not the reasons that you don't think. So user bin Perl, which is a standard place to put Perl, by the way, and you do -b, and you see that it's version 34 of Perl, as opposed to the latest Perl, which Perl -b, and you'll see that's version 40 or something. It's a newer one, right? So we have this Perl interpreter that's living around, and this, how does this relate to Bash? Because Bash is going to do the same thing. And how do you make it not the absolute path? Okay, that's the point I'm getting to. So there is a trick we can do using a program called ENB, which is on every single Unix-like system in the world. And what it does is one thing. It looks up the thing in the path and runs it. So let me show you what I mean by that. So we can take, so you remember that Perl code, right? Temp Perl foo. And we're getting to Bash. It's the same thing. So, and it runs it, right? But I can do, remember how I could do this? I can do Perl this. Same thing, right? Well, I could do this. I could do user bin Perl. Okay, I can do user homebrew bin Perl. Oops. It's opt, sorry. And it works too, right? So those are all different versions of Perl that are running it. Same with Bash. I could have done with Bash. Perl, I'm doing Perl because you have to explicitly put the interpreter line, and then we'll come back to the Bash stuff. So, and then what? Well, what if we said, I want to use whatever the same Perl is. I want to use this Perl. I want to use the Perl that's in my path. I want to use that Perl every single time, whatever one it is. Right? And why would you want that? Because which Bash is different? Check it out. Bash-v. This is a big deal on Mac in particular. If you do oopsie. Let's do, what is it? Bash version, I think. So Bash is 5.27 if you have it in brew. And that's why we did an installation. If you do user bin bash -- version, this is, we're getting back to Bash. This is why I'm doing this. So you'll see that, I think it's just bin bash. Yeah, I think it is. Yeah, there it is. It's 3.2. And the reason for that's licensing issues. If you can't see this version of the license was released under the Free Software Foundation and as a different license than this. This is GPO version 3, which is a license that is extremely incompatible with businesses, and you can watch Torvald's bag on how bad it is. That's why it didn't get put in. Why do you care? Because you don't want to have to write, you don't want your scripts to break when somebody runs it on a Mac or when somebody runs it on another machine. The whole point, and I made a huge point about this in the interpreter video I did before this one, the whole point of an interpreted language is it runs anywhere, right? Well, it doesn't run anywhere if the shebang line is wrong. So how do we fix that? We fix that by changing the shebang line to use this cool tool, which I hate doing this because it's extremely insecure from how I was raised, but it's good enough for your own shell scripts. And what we're going to do is we're going to make the shebang line into a program that runs and does the same thing as which. And so what do I mean by that? So if I do user, let's go back here. So if I run, so we do Perl temp. So if we do Perl temp, Perl whatever. Whoops. Oh, I think I killed my, I may have killed my, yeah, I did. I did some stuff with my bash terminal here. I'm going to need to get a new one, I'm afraid. Yeah. Okay, so yeah, okay. I think we're good. So, yeah, I did bash -x and turn it on, so it's showing every command I was using. That's what was going on. All right, so now watch. If we do this, we say, so same thing again, Perl temp / Perl foo. We'll do it with bash. Okay, no problem there, but watch this. User bin env Perl. You're like, well, what is that doing? That's kind of the same as which. As is showing you which thing. And what it says is find the Perl that's there and then pass it along and do the same thing. And you can do this with any interpreter. So let's do the same with bash. And then we do Perl temp boom, right? And so now that's running. What that does is it runs bash, but which bash does it run? And how would we know? Well, let's do that. Let's do this. Let's say, let's actually put some code in here. You remember bash doesn't need the shebang line because it's bash, but we're going to add it anyway, I promise. Let's go echo, is it version? I think it is. And let's try that now. Nope, there's no echo. What is it? Is it shell or is it, what is it? Yeah, env. So env normally shows you all of your environment variables. Okay, and you gotta be careful of doing this on a live stream, by the way, because a lot of people put tokens and stuff in their environment variables, and I could do a whole video about how I hate that people put secrets in environment variables, period. And the entire container world depends on it. I have debates all the time with people at work about whether it's safe or not. I think it's not. Anyway, so the env command by itself is pretty, pretty tame. It just shows you all your environment variables, but it has this special use which actually calls the command if you put the command as an argument, as the first argument. Is a bash version, thank you. So let's actually do this. Let's add, you don't know about variables, but you're going to learn very soon. So bash variables. So let's do this. So now when we run foo, we see that we're running the 5.2 release and not the 3.2 release, right? So the point of this is putting user bin env bash resolves bash at the place that you want. And why is that valuable? Because now I can make the same exact line at the beginning, the shebang line for both programs. User bin env, bash, right? And now I can run the program by itself, which I could already do, but now we're sure that it's going to be the right one and all of that, right? So let's go back to our Linux system and see why this matters. So we go back to our Linux machine, and let's actually write the same code in bash, foo, and we'll say, well, true, do done, echo, hello, sleep 1. All right. And then we'll put a shebang line in here, user bin env bash. And, it'll actually draw it now. But let's schmox that. Let's watch chmod plus x, foo, /foo, and it now runs, right? And you can probably tell, since it's kind of fun, let's do this. Let's do this. Let's do echo bash version. And we're going to use bash version again as an example of things. So there we go. Bash. There we go. Bash. You think bash RC is cute compared to Z shell? Yeah, it's best you not tell me that. It just shows what you really know. Anyway, the unfathomable power of bash tapping into any interpreted language that uses package modules is going to be a while. All right. Yes. Okay. So the point of this is very simple. Let's look at the first line of both of these programs, right? It's bash and then Perl foo. What is it? It's user bin Perl. Now let's fix the Perl one too while we're at it. So let's now use user bin env Perl, even though user bin Perl is literally on every system in existence these days. It really is. So it was only the containers are the only things that are really getting rid of it. This CLang thing is super interesting to me. Yeah, it's like it's something about my bash RC, which is making Perl complain. Anyway, so what are we saying here? We're saying that the moral of the story is thou shalt put these things at the beginning. We have 20 minutes left to learn the rest of the stuff in bash. And so this is actually a really important video about how to get going with coding and scripting. And we'll continue to start coding and introducing you to the ideas of what goes into the program. And then we'll chop this and we'll have a video that'll be what's a variable, etc. And we'll do that next. But let's go ahead and keep going down this path. So if we go back to our thing here, temp foo. All right, so double quote. Okay, so actually this is a good thing to talk about. Before we do any shell coding, this will be perfect for the rest of this video. Before we do anything else, so listen up, Chloe, if you're writing my description. She's going to be writing my description for this video. So here I want you to put a chapter marker for the beginning of a shell check. Make sure you put a chapter mark right here, okay, Chloe? She reads my transcripts and she does what I say. So I just had to talk to her for a second in the video. And so I'll do a separate video about how to have your AI help you make really great descriptions for your videos in 5 minutes. So anyway, let's try to start shell check. We're going to do shell check and we're going to talk about what shell check is. So if you're on a Mac, first thing you have to do, brew install shell check. All right, just go ahead and get the latest. If you're on a Windows apt-based machine, a Linux apt-based machine, sudo apt install shell check. This is the only things we're going to cover today. We're not going to cover any other method of installing shell check. That's how you install it. Once you have it installed, you should also install another tool. It's called shfmt, sudo apt install shfmt. And that will get you the other great thing. And so now we're going to go back to here. This has already been installed. Brew install shfmt. And so we're getting ready to do shell scripting. You should never script anything in bash without shell check. You just shouldn't. And I'm going to show you why while we're doing it. So let's continue to go down this path. Okay, so the next thing we need to do is we need to add some stuff to our vimrc and pretend like you don't have anything else in there. This is the one thing you do have to add. So before you do any shell scripting, it's probably worth your while to go do these things. Oh, whoops. All right. So, and we're going to go look for shell check. So I'm assuming you already have AL installed. If you don't have AL installed, you got to go back and do that. So if you got AL in here, we're going to put these linters in here. So add these lines, add these AL linters, and you don't need Perl. Actually, you don't need, yeah, there we go. So linter aliases, this is what you need. So because bash is already built in. So you should add this line right here. Okay. So add this line. I'll send it to you. Oh no, I can't. I don't have my WeChat running right now. Anyway, so linters. You need to add the linters for bash or thing, and then you need to add the fixer for the sh line and the bash line. Okay. Once you have those in, and then you should make sure you have lfix on save. The separate videos for all of this, but I'm just letting you know how my settings are so you can take a look. By having these settings on, then you get that really wonderful help that I just had, which gives you this. So this is being these help questions, these things that are being auto-generated in Vim or NeoVim by ShellCheck. So ShellCheck is telling you the problem I have. And if you don't have the time, if you don't think you have the time to do this, I strongly encourage to do it anyway, because the alternative to this is to do this. ShellCheck temp foo. And I used to do this. I used to do it with the NTR. So anytime the file changed, it would show me what my problems were. But and so we're going to go here instead. And we're going to say this. What are you talking about? Repeats twice. My live stream is repeating twice. You guys, do I have some kind of problem in the live stream? Am I echoing? You guys, am I echoing? Does nobody tell me I'm echoing? Please tell me I'm not echoing. I'm starting to freak out right now. You don't notice any echo. No echo here. Seems fine. I don't hear. Okay, somebody's saying live stream repeats twice. I don't know what that means. Okay, if that's an actual problem, please let me know. All right. So, okay, did you see how when I saved? I'm going to show you this again. Okay, so when I open the same program, yeah. Okay, so you see right here, I didn't bother formatting this or anything, because if you have SHFMT on, you don't ever have to care about it. The whole tabs versus spaces argument, which I just watched Silicon Valley about, doesn't matter. It's irrelevant. So here's what we do. You just save it, and it automatically reformats your code based on the standards that you have. Okay. So now you've got the standard here, and it's the exact same problem, but you can see right away that there's a problem here, right? It's like you need to double quote to prevent globbing on word splitting. So I only have a few more minutes left in this video, and then we're going to get really into bash in the next one. But what I want to end with is this. The best way to learn bash is by ShellCheck. Because you're going to go in and you're going to Google a little bit, or you're going to search or read about what you want to do. And we're going to cover that in the next video. And the next thing you're going to say is, well, why do I want to do this way? And what I'm trying to tell you is, you see down here, this is really important. SC2086, right? Now, if you have an AI, I'm going to do it right now. I'm going to go do it right now. I was like, tell me about SC2086. ShellCheck 2086. I'm giving you the strategy for how to learn this, so that as we go, I'm only going to show you the basics, but I want you to be able to do it. And my AI is pulling this off the internet. You can go pull it off the internet directly if you want, or you can just read your AI and say double quoting ShellCheck blah blah blah. What does this mean when you do blah blah blah? It does this, this, and this, and this. And it tells you exactly what to do. Here's a problematic code. Here's the correct code. How to handle this. Here's the rule of thumb. Enter exceptions to blah. Here's how you add an exception. Avoid this in most cases. The common pitfalls. So yeah, here's exactly how to do it. Final notes. All right. I just got a 4-page professional textbook summary in my AI of the error that I just had because of the code. It's one of the greatest things about ShellCheck. By the way, the AI is just getting that information from the official ShellCheck code, which you can go look at if you want to. But if you're following my recommendation of getting yourself ChatGPT, or I don't care which, get yourself any AI assistant, and you can go ahead and you can use the AI assistant to answer all the questions for you. And it might be wrong. If you want to do the research yourself, you want to say, hey, what are your sources? You can say, what are your sources? so that I can go check. If you don't trust it, because it does make mistakes. Chloe, I love her, but she does make mistakes a lot. There's the official documentation. If you want to have, if you don't trust an AI, you can still do this. You can just open the link up in a web page and go to the official thing. In fact, it's not that big. It's not that hard to do. It's following shellcheck.net wiki/sc whatever. So you can just, if you want to, you can just bookmark this and put this in. You can even make a shell script to pull it up for you. And then you could go look up that thing. By the way, that should be one of our projects. Let's do that for Bash. Let's make a project that automatically opens the web browser to the wiki page for you when you have a problem, and you can just put in the number. Wouldn't that be cool? So let's do that. So if we have that, now you can go read about the whole problem right there, and you can teach yourself while you're writing the code. You're going to be doing this your entire career. So if you've set up shell check properly, while you're doing Bash and doing advanced things in Bash, you can eventually go in here and figure out how to quiet these different problems, and you can teach yourself as you go. So having said that, I think it's probably time to finish the video. You guys can get all of those things set up for yourself, and that'll be the end of this video. And so please stay tuned for the next in the Holiday Boost series. I think we're going to be on 9 next, and we will continue. We'll actually jump right in to coding in Bash, both from the command line and in a script like we've been doing. All right, talk to you in a bit.